Well, hello everyone, and welcome back to Adrian's Digital Basement. What you see on the bench here is the TRS-80 Model II, or kind of what's left of it. And it's in this video that I hope to at least get this thing attempting to boot. In these bags right here are all the digital cards, like the CPU cards, stuff like that. I haven't even tested or done anything to these other than a little bit of an inspection. So I have no idea if these work. But in this video, I want to at least try to see. And of course, it was the last video where I worked on the disk drives and I made a boot disk, which is what's in my hand right here. So if this indeed does work to the point it's going to try to boot, at least I can see it boot. As I said in the last video, the keyboard is non-functional at this time, and that is definitely not going to happen for this video. In fact, I may run into issues and not even get this computer booted in this video, but we'll see what happens. So without further ado, let's get right to it. This is the power supply board, which definitely needs a going over first before I even attempt to power any of this stuff up. Let's first just do a visual inspection of this Aztec switching power supply. I've already given it a quick dusting to get off most of the bug debris and the spider balls, and things actually don't look too bad. There's definitely a little bit of corrosion here or there, like I'm noticing on these screws here. There is a little bit, and over here on this component there was some rust as well, which I did dab a little bit of rust converter onto those two screws. So I actually need to do the same over here just to kind of stop that corrosion from getting any worse. The schematics for this are available in the technical manual for the Model II, so if it does need repair, I can reference that. But without even looking at that, it's pretty easy to figure out what's going on here with this supply. We have the mains input right here, we have a fuse, some filters, an inductor. This is the bridge rectifier. The high voltage DC is then stored in these capacitors. This Aztec control module is a little unusual. It's a big block. It's probably potted inside, and it's got the control circuitry in it. Modern power supplies, this would be like a little tiny surface mount IC on the backside, or some of the older ones, it would just be using transistors. So I think this was trying to be advanced more than, say, the typical switching power supply at the time, like the one in the Apple II. This will actually generate the switching frequency needed to drive the transformer. And that's happening probably through this little gate drive transformer. And this is probably the switching transistor that is doing the high frequency switching of this DC high voltage to turn it into the other rails. So like I said, this is the main transformer here. And then out of this, we have the bulk capacitance that is the lower voltage DC rails that goes through these diodes that are mounted to this heatsink right here. One thing that makes me happy is over here on this heatsink, there are these bead type diodes here. And these are the older, higher current types. We would use a plastic casing now on more modern diodes. The problem with these is moisture or corrosion can really affect these, and they can basically just disintegrate or break off. David Murray, the 8-bit guy, had a video on an Apple II monitor that was found in the trash basically, and that had some diodes like this, and those were just gone. Luckily, if these were broken, I do have the actual schematics, or I can access the schematics for this power supply, so we could replace them with more modern components. And over here, this large square connector is the DC output for this power supply. This generates a bunch of different rails, +5, -5, +12, -12, and also a +24 volts, which is used specifically with the 8-inch disk drive. That takes 24 volts for the logic and I think the head stepper that moves the head around. There's one very important fact with this power supply, and I'm just flipping it over to the back. You cannot operate this with no load. It warns you in the technical manual that it can damage this power supply if you do that. And it tells you exactly what you need to do to load up this power supply. And one of the big problems, of course, for me, if I want to try to do that, is I have to figure out a way to connect the DC output to this rather large chunky connector here. Obviously I could cut the cables that are on the computer, but I'd really rather not do that. So I'm not sure I'm going to try to load this up with resistors as opposed to testing as much as I can on here without powering it on and then hooking it up to all the components of the computer to see if it works. So when trying to figure out if a power supply like this is going to work, one thing that's very destructive to a power supply like this is if the semiconductors, which specifically are the transistors and the diodes, are shorted. Shorted semiconductors can result in a bit of a cascade failure, which can cause substantial damage to large parts of the power supply. And while everything on here is probably obtainable, there's one part that's not, and it's this Aztec switching block here. If this thing is bad, the only thing I can do is replace this entire board with a modern power supply that has the equivalent rails. But before considering any of that, I'm just going to go over this and just check that all the diodes and the bridge rectifier are not shorted and look good using the diode test on my multimeter. One thing to consider when testing these is that some of the diodes are connected to inductors or they're connected to the transformer. That can cause the multimeter to beep as if there's a short. But there's a difference between a dead short, where if I hold my leads together, it's gonna read zero, all zeros, versus it beeping, but it reading something like if I measure this diode here, it's like 0.1, or one of the ones over here was doing it too, but it was like 0.08. Definitely was not a dead short. So all the components look fine. The last thing to check is the large switching transistor right here. And the two center pins on here are reading as a short. It's 0.0004. It's really a good trick if you suspect a short to switch over to resistance, because an actual dead short, if I hold the leads together, you know, we're getting 0.006 ohms or whatever. You might want to zero out your multimeter. But yet on the two pins on this transistor, it's 0.52 whatever ohms. That is definitely going to be going through the windings, because that is going to be hooked up directly to the transformer and the inductors and stuff that are on here. And actually, looking at the two pins that are on that large transistor, both of them go over to that large Aztec control block, while the case or the body actually makes its way over to the transformer. So from one of these pins to there, let's see, should be getting a voltage drop. Yeah, 0.45 volts on that one and 0.45 volts on there. So I really don't think there's a problem there. If anything, there's a problem inside that large block, but I won't know for sure until I actually power this on. All right, next up I have the Lcr meter out. I want to see about these large caps. They're almost certainly going to be fine. You know, I don't think I've ever found a bad bulk filter cap on any of the components I've ever worked on. Looks like these are rated for 470 microfarad. Yep, they are. 521 microfarad on that one, and 513 on that one, and a very low D value. So I'm going to say those are great. Now I have these electrolytics to quickly check. These are all 1,000 microfarad, and then these over here are shorter, 220. And then I have this cap here, 1,000 microfarad, 1,000 microfarad, and this one is 2,200. Now, unfortunately, on the back of this, it doesn't actually mark what's the positive and the negative. It doesn't even mark where the components are. So I'm gonna have to do quite a bit of back and forth to see where the component is, if I'm on the right two leads, and then which is the negative pin, because polarity does matter when you're testing with this meter. So far so good on the caps. Now all of these ones here, or a lot of these, are in parallel with each other, so measuring with this meter is gonna show much higher readings than expected. So for instance, this one right here, this tall one, seems to be in parallel with 1, 2, 3, at least 3 of the caps. And when I measure with the meter, we are reading about 3.8 millifarads. I think that's MF instead of a UF. And that kind of makes sense because these are 1000 microfarad and there are 3 of them. So yeah, all the caps, they seem to test fine. Like I would have to remove them from the board to really know if any individual one was working. But these ones all in parallel seem to add up to values that make sense and they don't have super high D values. And I think the only other problem that might arise with this thing is that some of the resistors can be out of spec or open. So I'm probably, you know what I'm gonna do? I'm gonna grab my multimeter and I'm just gonna quickly go through all the resistors just to make sure that none are open. I don't think an open resistor is gonna result in any kind of like catastrophic failure, but it just might prevent the power supply from working. And I may as well know before I mount this in the computer or on this metal bracket here and stuff, just to see if all the resistors are gonna be okay. Okay, so you know, I'm not comparing it to the actual value on here. Probably what I'll do is if I see anything in like the meg ohm, that's like, you know, 10 megs or something, I'll compare it to what the stripes on the resistors say. But I'm just looking for resistors that are open, meaning like there's nothing or they're very high. Anything else I'm gonna consider okay. All right, I think I've sort of gone over everything I can. There's a few tantalums on here, little teardrops. I checked those as well, just to make sure that those weren't shorted, because we know those like to short. Actually, one more thing I'm gonna do, I'm gonna use this little magnifying eye loop, and I'm just gonna give a quick look at the solder joints at an angle, see if I see anything that's cracked, and if necessary, I'll reflow those. I think it's going to be impossible to see, but over here on this is the DC output connector. Some of these pins over here on this side look very suspect. I'd say it's pretty typical that you're going to have cracked solder joints on things that are either heavy or connectors, because there's just the in and out of connecting it, plus the wires are pulling on it and whatnot, often have weak joints or cracked joints. And now I think I'm actually done now. It was really just the connectors that had the sketchy solder joints. Everything else looked totally fine. So there was this metal plate here, which was quite rusty. One side was the power supply, one side was the CRT. I think this was kind of a gold color, some kind of a coating. I have since sanded it down, tried to get all the rust off that was on here, and I sprayed it with rust converter. This was stuck to this side, which I'm pretty sure is what was underneath the power supply here. And that was just to ensure that you didn't have any shorting between the power supply and this metal plate. And through the magic of video editing, the power supply is mounted onto the metal bracket. In addition, I've also gone ahead and mounted the CRT board, which we've tested in, I think, part 2, so I know that that works. And I think it's time for a little bit of a break here with a soda. So what we have here is, hopefully it's focusing, grass flavored soda, mowed and bottled in the USA. I'm pretty sure that this stuff does not actually contain grass. It's probably sweet and sugary, kind of like the dirt one, which I had previously on the channel. All right, look at that, it's carbonated. Yes, look at that fizz, nice and bright green. Let's see how this tastes. You know what's interesting is that actually has a little bit of a taste of grass. Like, I don't even know what grass tastes like, but if you've mowed your lawn, the smell in the air and the taste you might get in your mouth a little bit from the really intense odor of the grass, it's kind of like this. And you know what's weird is it's not entirely unpleasant. It's fine. I'm gonna drink this entire bottle because it tastes not bad. Yeah, that's pretty tasty. Interesting. I think you can get this and the dirt flavored soda on Amazon. So if you're looking for this stuff yourself, you can get it there and you can try it yourself. Oh, and also I think you might have just heard a beep sound. It's the 286, the 5170 is powered up, and I'm running format QM here, and I'm formatting some 1.2 megabyte disks here. I'm just making sure that they all work. I had a box of unopened ones, and I'm just going through and just checking to make sure that they are all good. So far, they're all formatting perfectly. All right, so with this stuff mounted, I'm just gonna put this out of the way, and I think it's time to work on the disk drives briefly. Now you're probably wondering, what's he talking about work on the disk drive? He just had an entire video about these 8-inch disk drives. What I wanna do is just take off this mounting bracket on the bottom here and switch it over to the other 8-inch disk drive, the one that's a little bit less worn out than this one. It appears the mounting bracket is held on with these two little bolts there, and I'm just gonna break off this little bit of, I don't know, fluorescent glue or whatever they put on here to keep these screws from coming out. There we go. It was pretty brittle stuff, so it just snapped right off. And these are really tight. There we go. Wow, two-handed. All right, and in with the other one here. Ooh, so heavy. Okay, there we are. The bracket has been transferred. All right, and flipping this drive over, I had said originally that I was going to take off these 4 jumper blocks and run the jumper wires over to these 4 pins here so that external terminator block would work. I decided not to do that at this time for testing. Ideally, I'd like to replicate the way it was on the other board with a wire wrap tool. I actually need to buy a wire wrap tool. I've been meaning to buy one for the longest time. I actually have some wire wrap, but then I can replicate the exact thing as opposed to, say, soldering some wires. Although I suppose I could just use little push-on leads, DuPont type things. Those are so flaky though, they just aren't good in the long term. So wire wrap would be ideal. So for now, I'm just gonna leave it with the jumpers so it's gonna be solid and reliable, and I just won't be able to plug anything in to the back of the computer if I wanna add external disk drives, but I don't plan on doing that anytime soon. We're now looking at the base plate that holds the entire thing together. It's like the chassis of the Model II. And I know it's a little bit ugly, but there was some corrosion on this as well. And I did paint it with a little brush with the rust converter / black paint, which is what's going on here. I'll say again that I'm fully aware that a full restoration of this machine would involve taking this thing completely apart and sandblasting this metal, getting it powder coated, you know, the whole 9 yards. But again, I just want to put this computer back together and have a working machine, and some paint inside here is not going to affect anything in a negative fashion. And what it will do is stop further corrosion from happening. Not to mention, when this thing is fully reassembled, you're not even going to barely see this paint any longer. There's also something I didn't mention when I took this apart, and this little dent right here is a sign of what this computer has been through. I think this machine was actually dropped. And as the disk drive sits right here, it's clearly the heaviest thing in this machine. When it was dropped, it kind of bent the entire bottom chassis quite a bit. After I took this computer apart and I was just looking at this base plate, I noticed that the entire CRT assembly was quite bent as well. So I kind of hammered it back into shape a little bit. These dents are still here from the floppy drive. I don't think that's gonna cause any kind of issue, but I think this entire base plate is in better shape now than it was when I took the computer apart. But one horrible side effect of that is it had actually tweaked the card cage that was holding all the various cards. And it had the side effect of really damaging this top slot. Notice the gap on this top slot looks bigger than all the other slots. So I think this slot is actually broken. So when I squish it with my fingers, it moves. And when I do that on these other ones, that doesn't happen at all. So I have a feeling it snapped all the way along here, although I don't really see any damage on the outside. It just looks like there may be a problem here. So I'm gonna avoid using this slot and I'll just use the rest of these. Luckily, the electrical connection between the slots is the same on every single slot, so there's no difference between plugging something into this slot or the one below it. This is one of the metal sides to the card cage, and you'll notice there's some spray paint here, and there's quite a bit more of it here, and that's because, again, there was some corrosion and rust on this part of the board, so I did that thing where I sanded it again and I spray painted it. And I know, again, it's not super nice looking, but once the computer's back together, you won't even see this. So I've talked long enough. It is now time for a time-lapse montage of me assembling this thing. There really were a lot of screws on this thing, so using the iPad was very helpful to try to figure out exactly how it goes back together. What I'm working on here is the mains power distribution block inside the computer. And yes, it's completely exposed when it's inside the machine. It just sits on the bottom. I found the power switch to be a little gummed up, so a little Deoxit F5 fader lube made it work really smoothly. I realized that I didn't have the wires on the correct positions on the distribution block, so luckily in the service manual there's actually a diagram that shows you how it should all be connected, which I'm referring to so I can fix the wiring mistake I made. If you are taking apart or trying to assemble a Model II, I really recommend you reference the technical manual. It just makes your life a lot easier. If you remember all the problems I had taking the parts out of this machine, I decided to reattach the disk drive with only 3 of the mounting fasteners, just because that 4th one was so difficult to get to between the card cage and the drive. All right, I think I'm pretty much ready to go. So everything is connected except for the power supply mains, which is just unplugged right here. And I also have the monitor not plugged in. The CRT neck there is not connected. I want to plug this into mains right here and turn on the power. Now, nothing should happen except the disk drive should spin and the fan should spin. If that works and the circuit breaker doesn't trip in the house, then I guess I'm ready to connect up the mains to the power supply, which should power up the digital section and the analog board for the CRT. And I guess this thing is going to work or it's going to smoke. This is the power switch that goes on the front of the machine, and it actually switches both the neutral and the live. But it is a little scary in that all the wires are exposed. So you can easily touch this and get shocked. So I'll be using the isolation transformer when I test this. And I think I'll put a little electrical tape on this as well, just so I keep my hands off of that. One thing that's a little interesting is the fuse that's on the back of that panel that was all rusty. This one right here. This is only for the disk drive. I assume the power supply has a fuse on the board itself that if it were to have a problem, it would blow. You have to take the back cover off to fix that. So I don't know really why they put a fuse for just the disk drive. It's a little strange. Okay, I think this is the off position the way it is right there. And I'm gonna plug the mains into the isolation transformer. Okay, with it plugged in, nothing happened. So let me flip the power switch. All right. The disk drive is spinning and I hear that fan down there spinning up. It's kind of noisy. Okay, let me turn this off. Okay, so I'm plugging the mains into the power supply. All right, need to connect up the CRT board. Looks like the gap in the pins is right there. If things actually work, I'll dress these wires with zip ties. For now, I just have everything loose because I might be taking this apart again. And I think now it's time to turn it on. And I gotta say, I'm very nervous right now. I just, I don't know what's gonna happen here. I mean, I know the disk drive works. I know the CRT board works. Power supply, I think, should work. And, you know, these boards, who knows? So, you know, is smoke gonna come out of it? I'm gonna leave the main camera pointing at the back in case anything smokes here. And I'm gonna use my phone recording video to capture if anything comes up on the screen. Alrighty, here we go. I have no idea if anything is actually working and if we have voltages. Seems like nothing is happening. I hear the power supply doing something. It's like seemingly working. Oh, and the CRT is actually lit up, the filament, but we have nothing at all on the screen here. Let's see if I can adjust these pots. All right, well, getting nothing here. I suppose I should check voltage rails. All right, hopefully you can see what's on the screen of the multimeter. 26 volts there. I don't know what that one's supposed to be. 5.0, that looks good. 5.05, minus 12.1. I'm not sure you can see the minus there. Yeah, 12.7, that's a little high. All right, actually on the power supply, we have plus 5, plus 12, minus 12, and plus 24. There is no minus 5 on the actual power supply. So I was seeing all of those rails except for the plus 12 was just a little high. And the filament on the CRT looked like it's glowing a little hotter than it should. That's going to run right off the 12 volts probably, and it's being driven at 12.7. According to the operating characteristics, it should not be exceeding 12.6 on the 12 volt rail. So that is definitely out of spec. I'm just going to turn this off. I'm just checking to see if anything is hot on here. All these caps are not hot at all, so that's a good sign. That matches what I saw with the ESR meter, how none of the caps seem to be out of spec. Now, I don't think any of the power supply rails on here are adjustable. They should be within spec, but it might be that there's insufficient load on the 12 volt rail, and that's causing it to be a little bit high. I know the monitor PCB was getting power because that's this connection right here, and the filament was glowing. But if this computer is not booting, then that means that the monitor won't be getting horizontal and vertical sync pulses, which means it won't be running. And it will draw additional load on the 12 volt rail once it starts to run. So it could be high simply for that reason. Now I just realized that this front panel has a power LED that connects to probably the CPU board. So I'm pretty sure this cable here is shared with the reset switch right here. And unfortunately, the reset switch is damaged here, so this is not working. Should be fixable, I think. So I'm just going to turn it on, make sure that the power LED does indeed light. So here we go. All right, yep. We do have, of course it lights, right? I mean, 5 volts is coming from the power supply, and it's getting to, well, it's most likely getting to all those digital cards, and that's where this is powered from. I'm feeling for high voltage on the CRT though, and there is none. So that pretty much confirms there's no horizontal and vertical sweep happening right now, which means either the CRT board has a problem, the RAM board has a problem, or the CPU board has a problem. Any three of these could be bad, and you know, maybe I should just take out the disk controller because that's not necessary for the machine to turn on. And while I'm at it, I'm just gonna give all the socketed chips a little bit of a push. I think I kind of forgot about this, but while pushing down the chips, take a look at that Fujitsu IC there. Not looking so great. That leg there is a little rusty. It's very common for these Fujitsu chips of this era to get corroded like that when they're not in perfect environmental conditions. We do the same thing with the push on the CPU board here. Obviously I have not done it because these chips are all kind of going back into the sockets there. Oh, there's a couple more here. Unfortunately, this has some of those Fujitsu ICs as well, and they are also similarly crappy looking. All right, they're back in. Let's see what happens. As you can see, it's still a no-go. Well, you win some and you lose some. Clearly, this machine is not working. We know major components are functional, but the one variable was the digital section, and clearly that's not working. Those Fujitsu chips that were all rusty in those sockets, I think those are bus transceivers, and they're not normal 74LS logic chips. So I'm gonna have to figure out what the equivalent is, or maybe order some of those and replace those sockets and replace those chips, or at least figure out how to test those chips. So that'll have to come up in the near future. I can't deny that I'm a little bummed that this isn't working because I really was excited to see this thing actually start to boot, so I could start to attack the cosmetics of the outside of the case and that keyboard, and then maybe have a working TRS-80 Model II. I'll probably be taking a little bit of a break from this machine just for a little while because there's a bunch of other projects I'd like to get to, and this machine has been taking up a lot of my time and bench space. But now that it's at least together for the most part, I can pick this up and move it as a single unit. So I hope you enjoyed this video and watching me unsuccessfully get this machine working. If you did, a thumbs up would be greatly appreciated. You know, all the YouTube subscribe, stuff like that. Comments down below if you have any. And of course, thanks to my patrons, their names are scrolling up the side of the screen. I really appreciate the support they've been giving me and the channel. If you want to become a patron yourself, you can do so at the link in the description below. And of course, if you're just stumbling across this particular video and don't know what the context of this machine is, there'll be links in the description to all the previous parts about this machine. So I guess that's going to be it for now. So stay healthy, stay safe, and I'll see you next time. Bye-bye.